Gradle 7.5 contains some exciting updates. Here's an overview of the major changes. For more details, including demos, check out the longer format video linked in the description below.
This feature allows dependency resolution results to be used as task inputs, right? We commonly use, right, dependency resolution as task inputs when we think about like simple file collections, right? But more rich models of like the graphs and all that, tasks could implement and get those results, right? But not as inputs and not in a configuration cache friendly way. Now with this release, we have proper APIs that are supported by the configuration cache. The first one is the ability, right, to just get a fully resolved component graph, right, as an input to a task. So you can navigate the edges, see the dependencies, which components were selected, for which reason, and all that. And we also introduced the ability to get a list of all the component artifact identifiers, right? There'll be like a flat list of everything, but also with metadata, right? So you can see why that a variant was selected, for instance, and things like that. For the next configuration cache improvement, we tackled the ability to run external processes in a configuration cache friendly way, right? Previously, external processes were allowed, like you could use the exec, Java exec APIs, but the output of such process were simply ignored. And you can imagine that would be a problem, right? If the output of a process actually is used to affect configuration in any way. Here in this sample, I'm just doing like a very synthetic example where I set the property of some task to be the result of this Git output execution. So with 7.5, we introduce this new provider-based API. With this, now we provide, right, no pun intended, new APIs that allow you to get providers, right, for like the text output or the bytes output of a process. And just to show, right, so this is a synthetic example. Again, I just access, right, I made the example access the output of the process at configuration time. And again, just configure the task with that value. When we do that, right, we can see that in the configuration cache report, we can see there's a new output that is identified now. So we see the output of external process Git by this plugin. So there's a better way, right? And the better way, as you probably imagine, is not to access the output at configuration time if you can, and simply wire the output of a process as an input to the task. When you do that, you see that that process output is no longer a configuration cache input. For more complex scenarios, right, maybe you have to call like lots of different processes. You have to involve different inputs from the environment, right? We have the value source API, which is supposed to represent these external contributions to the configuration cache. And starting with 7.5, inputs that are used in the context of a value source will no longer be detected as configuration cache inputs. Only the final result of the value source will be checked. The report will include, right, when you have a value source, you can see that we see a value from a custom source. We can see the provenance of that source. So now talk about another type of input. So let's say configuration logic, like build logic, just uses, right, Java IO APIs to access files and whatnot. So before 7.5, right, those would go unnoticed. In 7.5, we actually instrument and detect a few APIs. We don't detect every type of access. This will still come once we implement a new solution to how we instrument, right, the execution of the configuration phase. But for now, you start seeing more and more of those APIs being covered and then providing inputs, right, and then appearing in the report, as you can see here. We introduced this new API, environment variables prefixed by and system properties prefixed by. So this common pattern can now be used in a very efficient way, right? So now only those system properties or environment variables that actually match will be considered inputs to the configuration cache. And as I mentioned before, the value source gain also this special power that it can read the environment at will, and nothing will be considered an input, only the final result produced by the value source. So we also had a few new improvements to plugins and tasks. So the Kotlin DSL plugin is configuration cache compatible. And since we also implemented this dependency resolution results as task inputs, some of the tasks that actually use dependency resolution results to generate reports like Dependency Insight, Outgoing variants, and Resolvable configurations were improved. We introduced a new stable configuration cache feature flag because it's actually a significant effort to migrate, still is, to migrate a complex build to the configuration cache. So we decided to introduce this flag. So the more disruptive validations are now behind that flag, right? So for instance, using external process via this legacy Java exec and exec APIs, right? If you enable that stable configuration flag in your build, this is what you would see if you wrote code like that one that I showed you on the first slide for the external process, right? And this is actually an error. You would fail the configuration cache, you would fail the build and all that.
So I have a feature of 7.5, which is a new API for dependency resolution, dependency management. So we have this problem where when we are trying to pick what kind of variant we want from a dependency, we kind of rank each variant based on its attributes. And in some cases, you can actually have two variants that rank identically. They have different sets of compatible attributes. With the way it worked before, there was no way of Gradle choosing, and so Gradle would just blow up saying, I don't know, pick one for me. So we added an API that allows ecosystems to define what order to consider the attributes in. So basically it means that attributes that are higher in precedence, if they disambiguate the result, they win. And then otherwise it goes through normal disambiguation.
For test workers in the past, we were opening modules since we had code that were running in test workers that required interacting with some JDK internals. But in some cases, if you wrote tests that would touch JDK internals and you didn't open these modules in your production code, you could actually have unreliable tests. So what we did here is we removed these openings. So then the tests are more reliable, and you can be sure that if you are touching JDK internals in your tests, that it'll actually fail.
So we improved the outgoing variance report. This is an existing report that's used to investigate unexpected dependency resolution outcomes. So you have a scenario where you have a producer project and a consumer project, and you want to know why the consumer project is picking a certain variant of the producer. So you run this report on the producer side, and it's meant to be the easiest way to view everything available for selection. We did some work to improve this report, improve the output format, clean it up a little bit, add some additional information to it. So this is a new report that we added called the Resolvable configurations report. This is the complement of that outgoing variance. So in that producer consumer scenario, this is a report you would run on the consumer side, and it would give you similar information. What attributes are on the configurations that I'm trying to resolve. So by running these two reports together in a producer-consumer scenario, you can get to the bottom of why was a particular variant selected and others not selected.
For 7.5, I added Dependency Insight report improvements. This is a set of changes to the Dependency Insight task, which allows you to display variants of certain dependency. For this particular change, I added a all variants flag, which you can use to display every variant of a dependency that can be used in dependency resolution. This can be used to see what attributes needed to add if you want to select a different variant. The report also now uses a table to display these variants, which allows you to more easily compare and contrast which ones are selected or not, and this has some details as you can see here. I also added Java 18 support. This is pretty simple. Gradle just now supports running and compiling with Java 18, so if you want to run Gradle with Java 18, you can, and it won't cause any problems. I also merged in a community PR which added additional flags to our Groovydoc task.
A feature that was added to the properties task. The properties task allows you to list all the project properties of project. but often on CI or for keeping track of specific properties, you want to specify only one or a set of properties you want to list. It's pretty simple. You invoke Gradle properties -- property, the name of a property, and you get only this one. So we made some changes to how JVM toolchains are resolved to follow up on the kind of a mess between adopt OpenJDK and Adoptium. So we now check the Adoptium API first when downloading JDKs and fall back to adopt OpenJDK if we cannot find a suitable JDK. So we also added some system properties so folks can override the base URIs to the services. And anyway, all this should go away soon because we are working on making the resolution of JVM Toolchains pluggable. So we will end up removing this from the core. Some work has been done also to improve how Eclipse see test sources from test fixtures, test suites, and so on.
Continuous build is the feature of Gradle that automatically re-executes the build whenever the inputs change. So you would start a build with -t, for example, like running something or running a server, and then we would change any source file and then it would rerun the build and redeploy the server and do some auto reload. The problem we had with that we have been using internal APIs so on macOS, the JDK APIs only support polling, which is not like the best API to detect file system changes. And the problem is with JDK 9, we were not able to set the polling intervals lower, so the actual polling interval was 10 seconds, which is like you can need to wait up to 10 seconds to show change. On the other hand, we also implemented file system watching, which uses our native integration to watch the file system. And the idea was to replace the old infrastructure by the new one. It's basically instant now.
Code quality tools got some improvements with this release. First to mention is check style. Check style tasks now use Java toolchains. That means that you can set the Java version you want to run check style with. Now, a nice feature is also that for Java project, if you set a Java version on the Java extension, check style will automatically pick it up. And then another thing, check style tasks now use worker API, and with that, check style now run in parallel within a project for every source set. With that, you might see some performance improvements, especially if you have a lot of sources. Now, if you have just main and test source set, you might not see much of improvement, but if you also have like integration tests, functional tests, stuff like that, there might be some improvements. Next thing is PMD improvements. This was contributed from the community, so that's nice. Option to run PMD with multiple threads was added in this release. And with that, you might see also some improvements if you have a big source set with a lot of file in it.